Since we looked at data distribution, we talked about standard deviation, we talked about variance, and how that connects to how spread out the data is, let's start looking at two things here. One, Chebyshev's theorem, and the other called the empirical rule. If you don't know the distribution of the data, you don't know if it's symmetric, skewed, uniform, bimodal, you don't know anything about the distribution, we have this idea called Chebyshev's theorem. And Chebyshev's theorem basically says this. It's this formula, 1 minus 1 over k squared, where k is your number of deviations away from the mean, your number of standard deviations away. So for example, if I have a mean of 50 and a standard deviation of, let's say, 6, if I want to go k equals 1, basically what I'm saying is I take 50 and I add and subtract my standard deviation one time. And that will give me 44 to 56. One deviation away, so I take one deviation and I add and subtract it. Well, if I take in k and I plug that into the formula, I'm going to end up with this, which gives me 0. Not really a big deal. What this says, and it's not going to be anything major, at least 0% of the data, at least 0%, falls in this interval. Not saying a whole lot to us. What we're saying is we don't know anything about the distribution. So we don't know what percentage is going to fall in there, but it's at least 0%. Well, let's get into something a little bit better. What if k is equal to 2? Well, now we're going 50, and we're adding and subtracting the standard deviation twice. Now I'm going to end up at 38 to 62. And now when I plug that in, I'm actually going to get something of relevance here. I'm going to get 0.75, which we're going to make 75%. Turn these over to percentages. So what I'm basically saying is at least 75%, possibly more, but at least 75% of my data will fall inside this interval. Not less than 75%, but it could be as much as 100% as far as we know, because we don't know anything about the distribution. You could do this with k equals 3 or 4 or 5. You can keep on going up. But what if we know something about distribution? What if we know we're dealing with a symmetric bell-shaped curve? We're going to refer to this as a normal distribution in a little bit. And we're going to be able to talk about the empirical rule. So we're talking about a bell-shaped, mound-shaped curve. The empirical rule is also known as the 68, 95, 99.7 rule. Here's basically what we're saying. When we're talking about a symmetric bell-shaped, our mean and our median are going to be the same thing, and they're going to be right in the center, and they're going to be equal to each other. If I were to go back one deviation and forward one deviation, so I'm basically subtracting one standard deviation from the mean and adding one standard deviation to the mean, 68% of my information will fall inside that range. Not at least 68%, exactly 68%. If I go 2 deviations away, well, now instead of adding and subtracting one deviation, I'm going to add and subtract 2 deviations. Well, now I'm focusing on this 95%. And if I go 3 deviations, I'm looking at the 99.7. Let's look at an example. So let's look at an example here. If our mean is 50 and our standard deviation is 4, and we're talking about a symmetric mound-shaped curve here, we know that 50 has to be in the center. Well, if I were to subtract one deviation, I get 46. If I were to add one deviation, I would get 54. If I subtract another deviation and add another deviation, subtract another deviation and add another deviation, these are the magic numbers I'm going to end up down here. If we're talking about a symmetric mound-shaped curve, it is guaranteed that 68% of all data will fall between 46 and 54. 95% of all data will fall between 42 and 58. And 99.7 will fall between 38 and 62. Almost 100%, but do keep in mind there will be extreme values that fall below 38 and above 62. Not very many, 3 out of 1,000, but there'll still be some. The other thing to keep in mind is this is a symmetric curve. So if we're talking about 68%, half of 68 is 34, so 34% is on either side. So 46 to 50 is 34% of the data, where 50 to 54 is the other 34% of the data. And the same thing can be said, this section and this section end up being the same, and this section and this section end up being the same, simply because we're talking about a symmetric curve.